Boom. Hello and welcome back to Calculus 1 Exam 3 review. You voted, you want to have an exam, so what are we going to do? Have an exam, right?
Wait, is that tomorrow?
Yes. So what we have on this exam is Chapter 4. And that is on application of derivative. So you need to know how to take derivatives. You learned that in chapter 3, but you still need, right? Because you set derivative equal to 0, you do first derivative test, second derivative. So if you don't know how to take derivatives, it's not going to go well. So you need to know how to take derivatives, which includes basic and product rule and quotient rule. So basic, product rule, quotient rule, chain rule. I'm going to put chain rule with exclamation over here because it's very important, very frequent. So take derivatives. And then we go and we figure out that we need min-max, first derivative test, second derivative test, and then graph the function, so I will give you the information for this. You don't have to go and compute everything from scratch because there will be a separate problem for the first derivative test with analysis, and then the second derivative test with analysis and all of that. Word problems. On optimization, we are looking at farmer, at distance. You have the problem on the board, right? The distance formula, farmer problems. Those are the usually, there could be others. And then we have linearization, which is actually tangent line. So compute ln of 5. Compute square root of 20. And then we have differentials. Differentials measure the change. That's again word problems there. Yes. We have L'Hopital's rule for derivatives. Then we have antiderivatives, which is integrals. Yes.
Like specific theorem questions or anything like that?
Ooh, mean value theorem. I forgot about that one. Good. Because that's definitely going to be there. Mean value theorem. Okay, so to answer your question, what specific theorems or definitions to state. We don't have much. You have only mean value theorem. You have the formula for linearization, right? Lx equals to f of a plus f prime of a times x minus a. And then you have first derivative test with the conclusions, second derivative test with their conclusions. So that's 4 so far. And differentials formula. It's like 5 things. Concept-wise, to find min and max, you set derivative equal to 0, or where the derivative does not exist. If there is a point, should be min and max. You can use first derivative test for increase, decrease, and to figure out min and max. Concavity, also to find the concavity and min max as well, second derivative. What else? Make sure you can do chain rule. Anything else?
You said about first derivative, second derivative test analysis. So what do you mean by analysis?
Well, analysis is the conclusion, the answer. You will say that on interval so and so function is increasing. That's the analysis of the function. Where or what are the intervals on which the function is increasing, decreasing? That's what I've said the answer. Right at the end, when you do the problem, there is the portion where I said the answer, and I said f is inc, increasing, on, and then I wrote the interval, union, maybe another interval if there was one, and then f of x is decreasing, on, and then I write another interval. So you only provide x values there. You don't go point to point, you go x value to x value. So from, let's say, 0 to 3, on x-axis it's increasing, then from 3 to 5 decreasing, and so on. So that's what that's the meaning of analysis. Concavity for the second, do the same thing. Analysis means on interval so and so, function is concave up or function is concave down. Any other questions, concerns? Do you have any problems that? I thought that was already open. The whole chapter 4 should be opened. Anything else, guys?
Oh, what about the trait identity? Like, we should just have all of them.
Well, the main ones that are common knowledge, that's the ones that we need. Like if you are STEM major, the common knowledge, double angle, power reducing, Pythagorean identities.
Quotient and reciprocal.
What is the quotient and reciprocal?
Like sine equals 1
over
cosecant.
Yeah. Yeah, those fall into the basic, yeah. Those fall into the basic ones. Check on homework.
I meant like chapter 2.
Hmm?
I meant like chapter 2, throw that
Old school stuff. Yeah, eventually. Just wanna see. Wait, what chapter 7?
You go into like the interactive book to everything generate like an unlimited number of problems based on the type of problem you want to practice.
Mm-hmm. Anything else? Hopefully you're handing in labs ASAP. still have a lot of work because you didn't do it, right? Hmm?
Do we want to hand in any of the labs like before the final?
I don't think it matters. Like he was trying to have him by Monday. You can start the project. Great.
Yeah, Professor, nobody handed in 3 yet, right? We didn't, yeah. Does everybody have 3 done? Do you want to agree on a day for 3, or at this point?
Yeah, this guy was on fire.
So do you have any questions, any problems that you want to work out before I shut the stream, or?
Can you work some integrals? I really have a hard time with the integrals.
The ones from the...
Envision them, how to work.
So when you have integral of sine x dx, right? You can think about which derivative would give you sine, which function will give you the sine x as the answer, right? So that's what goes here, and then plus c. That's how that works technically. So derivative of what gives you the sine? Cosine. But remember, derivative of cosine is negative sine, so it has to be negative cosine here. Because the derivative of cosine is negative sine, then the derivative of negative cosine must be sine. So the answer is negative cosine x. It's backwards thinking. The only one that you have to memorize the formula for, because it's not backwards thinking, is x to the n, which is x to the n plus 1 over n plus 1 plus c. So that's the one. So if you have integral of square root of x, that's integral of x to the 1/2, which is x to the 3/2 over 3/2. I put half on top right away, my double fraction. The other ones is just memorizing. The integral of 1 over x dx is what? ln x. Because derivative of ln x is 1 over x. As a student, I loved integrals because I was always able to take the derivative of the answer and see if it's right. Like for derivatives, you memorize this thing, first, and then if you did it wrong, it's wrong, right? But for integrals, if you're not lazy, right, and if you care enough, you just go and spend additional 13 seconds on taking the derivative to check. If you get this, your answer is correct. If you don't get that, it's wrong, right? There's no in between. So taking a look at this answer here, let's say I want to check that. The derivative of 2/3 x to the 3/2 plus c. Derivative of plus c is 0, right? We don't have to worry about that because it's a constant. So how do I take derivatives? I take 2/3 constant, copy, drop the power down 3/2, x to the 1/2. These guys cancel. And there's your square root of x. So I know it's correct. So for me, integrals were just like a gift question every time. Because on the exam, if I get it wrong, I know it's wrong. And then I ask myself, okay, what is wrong? Where did I make a mistake? Is it simplifying algebra? Is it right? The other thing is patience, right? Not rushing into doing the problem. wherever I heard this, all things that are worth in life, they take time to develop, right? So, like a meaningful relationship, whether it's a friendship or a love or whatever, that takes time. It's not, you know, like in movies, a crisis and then two are together right away. So take time when you are doing the problem. If you have integral of, you know, square root of x to the 5th dx, take extra step to understand the problem better. Because at this point here, you know that you are supposed to add 1 to 5/2. Because you see it's x to a power. And then you know what to do. You know, take the extra step, make sure you're doing it right. So it's going to be x to the 7/2 divided by 7, and I put half on top immediately to skip that step at the end. But I like this step, this extra step, so I can make sure that I'm getting the problem 100%. Now, you take derivative of this, and you see that 7/2 kills 2 7s, and then minus 1 on top will give you 5/2, which is square root of x to the 5th. So as I said, if you're not lazy, if you care enough, its integration can be checked, and just by taking the derivative. So just, you know, take your time. Also, what's important with integration is that you can kick the constants out. So if you are taking the integral of 4x to the 7 dx, you can kick constant out and just worry about x to the 7, which is x to the 8 over 8 plus c, and then you cancel these constants and get your 1/2 x to the 8 plus c. So constants can be kicked outside. That's the important part. The product rule in integrals is called integration by parts, and that is in Calc 2. So we don't deal with that. So if you see a product, make sure you FOIL it. For Calc 1, it's really straightforward. So if you see x plus 1 times, you know, 2x minus 10, whatever, dx, you must FOIL, because that's the only way how you can solve this problem. You cannot integrate independently these. That doesn't work. Just like you can't take derivatives of each factor. You have to do product rule for derivatives. For integrals, you will have to do integration by parts. But that's Calc 2 in Chapter 7. So you have to FOIL here, and then you will get whatever an amount of terms you get, and then you deal with that. So that's FOILing. Also for division, if you have, let's say, you know, x squared plus 3x minus 5, and everything's divided by, what was here? X
Square plus 3 is
minus 5. I don't know why he erases things that I write. It's so annoying. Yeah. Sorry, I wanted to say x cubed on the bottom. So now you have to divide. You have to divide, and then you will have, again, something to worry about, right? Integral 1 over x, you know that's ln, right? Plus 3 over x squared, well, that's 3x to the minus 2, use the plus 1 formula, right? And then minus 5 over x cubed, again, n plus 1 formula. Right? And don't forget plus c at the end. We said it's not there for decoration. We absolutely need it. And we are going to learn how to compute the values for plus c. So you have to have that as well. Sounds good? What happened?
Values for plus c.
Yeah. So plus c will be, I don't know, 5 or negative 10 when you get the initial point. We can do that. Anything else? Well, that was integration talk. Patience, 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 and always think backwards. Which derivative would give me this?
What was the, remember you said the trick thing for that like step people need to know? Just now.
Or the power reducing, yeah. So the only way to solve this problem is to use the power reducing formula, which is, in this case, now you can see that you can kick 1/2 outside. That's the common. And then you take these derivatives, integrals independently for one another. You just make sure that 1/2 multiplies everything. So integral of x is, integral of 1 is x, and integral of cosine 2x is sine 2x, and you have to divide by 2 because you had the 2 right there. And then we have plus c. So this thing over here is called power reducing forms. You will need this for Calc 2 a lot.
Okay, on the exam set.
It should pop up. Power reducing formula. You have one for the sine and one for the sine, just as a minus in there. It looks the same. It also has a cosine 2x there. Now, how the evil problem, should I say evil problem, but let's say you have integral of sine squared of 3x dx. See, this 3 will get doubled when you use the power reducing formula. So you have the integral, there is 1 minus, because it's sine, you have a cosine of 6x over 2 dx. So the formula is always doubling this answer. And then you do your integral. You kick 1/2 outside. Integral of 1 is x, and minus, and integral of cosine is sine 6x divided by 6, and then plus c. So power reducing formulas will always double this angle. In the previous example, that angle was 1, right? So it became 2 on the other side. Anything else? Yes?
If you have linearization is like ln 1.07, so would I choose x equals 1?
Yes. 1.07,
Yeah.
you will choose 1, yes. Because 1 is the nice number close to 1.07. If you're using differentials, then your delta x would be 0.07, the difference between 1 and 1.07. So for differentials, we are using this formula, right? dy equals to function times dx. And dx is the same as delta x, which is always x2 minus x1, right? And dy approximates delta y, which is change in y's. So that's what the differentials do. They approximate the change.
So you good to go?
If you have no more questions, that's it.
Can I ask about the final?
Yes.
What does the final cover chapter-wise?
2, 3, 4, and 5.
2, 3, 4, 5.
Yes. We said a cumulative. You will take a look at all of the exams. I will do my best to bring exam back on Wednesday. So you take the exam on Tuesday. I give it back on Wednesday so you can review it. And then Thursday's cumulative will start. Final will be from 5 to 7. The class starts at 4:30, but you know, few questions and so on. We'll start with the final at 5, so 5 to 7 on Thursday. Chapters 2, 3, 4, and 5. Final in 6 days and 22 hours. Do what?
Third exam in 4 days and 22 hours. And then after that, final in one day.
I'll see you Monday.
I see you Monday.
I guess it would be 22 and a half. Not starting right at 4:30. I suppose. Sounds promising.
So whatever you work on in the finances, just send it back. Good night.
Good night. All right. Well, say bye to the stream. Oops.